Hey everyone, and welcome to the Foundry by Forge College. So today is a pretty exciting day because we're officially bringing an end to the lone wolf era of development. Now, if you've been following along with our previous lessons, you've already made that big jump from a solo dev setup into creating a proper repository skeleton. You've built the structural frame for your Solana project. But, a frame is really just a frame. In this explainer, we're going to draft the ultimate blueprint for a highly orchestrated, multiplayer development environment. We're taking that basic skeleton and turning it into a well-oiled, contribution-ready machine.
To really understand why we need all this extra plumbing, ask yourself, what exactly happens when 50 developers try to merge their code at the exact same time? Well, picture a professional kitchen. Now cram 50 enthusiastic chefs into that kitchen. But here's the catch. There are no assigned stations, nobody's agreed on a recipe, and they're all just aggressively throwing their own random ingredients into one giant pot. What do you get? Spoiler alert, you don't get a gourmet meal, you get a guaranteed spectacular merge conflict nightmare. Because without rules, collaboration doesn't scale, it just explodes.
Let's put these two worlds side by side. In the wild west of solo coding, you just write the code, push directly to the main branch, cross your fingers, and kind of just hope for the best. And hey, it's thrilling, but it's also entirely reckless. If we actually want to scale, we absolutely have to transition to a structured, automated factory floor. We are trading hope for PR templates, strict code owners, and fully automated continuous integration checks.
All right, here is our game plan for today's explainer. First, we'll look at the multiplayer coding problem. Next, we'll set the rules of engagement. Then we'll talk about defining code ownership right before automating the defenses. After that, we'll cover testing the automation. And finally, we'll make sure you are ready for the capstone. Let's dive in.
Section 1. The multiplayer coding problem.
So, as we established, a repository skeleton without explicit rules is basically just waiting to collapse the minute your team starts growing. It lacks the ligaments and the nervous system you need to coordinate complex updates. To fix this multiplayer problem, we're going to install what I like to call the collaboration plumbing. We're integrating 4 critical pillars into our project layout today. We need the rulebook to tell people exactly what to do. We need the forms to standardize how they communicate. We need the bouncers to, check IDs at the door. And we need the metal detectors to catch any dangerous bugs before they actually get inside.
Moving right along to Section 2, the rules of engagement.
Our very first pillar here is establishing unambiguous human-facing guidelines. We have to make absolutely sure that every single developer who clones this repository is reading from the exact same schematic from day one. And the home for these rules, that's your CONTRIBUTING.md file. Honestly, think of this as the constitution for your code base. It outlines the exact branch naming conventions, for example, mandating that new features have to start with // and bug fixes start with /. It defines commit styles so our automated change logs generate cleanly. And crucially, it spells out the exact testing commands like anchor test or cargo test so developers know how to validate their work locally before they even think about pushing it.
Next up in our rules of engagement are the forms. These are your pull request and issue templates. Look, when a developer submits a PR, they shouldn't be staring at a blank text box wondering what to write. These templates act as standardized forms, actively forcing contributors to provide a rationale, a summary, a documented test plan, and any Solana-specific runtime considerations, things like account migrations. In the community programs we run at Forge College, we see these exact templates save engineering teams countless hours of frustrating, back-and-forth debugging simply by demanding context up front. It is such a massive relief to just have that info right from the start.
All right, Section 3, defining code ownership.
Okay, so we've established our human guidelines, but let's be real, humans make mistakes, and sometimes they just ignore the guidelines altogether. That's why we have to move to programmatic gatekeeping. We need to explicitly define inside the system exactly who is allowed to approve changes to specific modules of our project. The hero here is the CODEOWNERS file. If CONTRIBUTING.md is your constitution, the CODEOWNERS file is the automated bouncer standing outside the club door. It's just a simple text file that lives in your repo, but it wields immense power. It looks at the files a PR is trying to modify, and it strictly checks credentials, automatically assigning the correct required reviewers before letting any of that new code near the main branch.
Take a look at how incredibly simple this mapping actually is in practice. Any change made inside the program's directory is automatically routed to the Solana program team. Meanwhile, a simple typo fix in the docs directory is just assigned to the docs team. By routing specific file paths directly to distinct team aliases, you completely eliminate the whole, wait, who's supposed to review this, guessing game. And that leads to drastically faster triage and review times.
Section 4. Automating the defenses. So, we have our rules and we have our bouncers. Now it is time to install the metal detectors. These are the automated continuous integration workflows that completely remove human error, fatigue, and, quite frankly, laziness from the code review equation. Using GitHub Actions, we create a workflow that triggers automatically the second a pull request is opened. First, the system sets up the required environments, your Rust and Node.js. Second, it runs strict linters to ensure code style compliance. Third, it attempts to actually build the Solana programs using Anchor build. And finally, it executes the test suite with Anchor test. These are your metal detectors, automatically catching regressions before a human reviewer even clicks open the PR.
Section 5. Testing the automation.
Now, an architectural blueprint is beautiful to look at, but it's totally useless until you run a diagnostic to prove it actually holds up under pressure. To verify our defenses, we run a simulated pull request validation. First, you intentionally create a test branch and push a minor change. Second, you open a PR and watch those CI status checks spin up automatically. Third, and this is the fun part, you try to force merge it before it's approved, just to verify that the code owner review gating acts as a hard, unbreakable block. Finally, you get the required approval, the checks go green, and you merge it successfully.
Bringing it all together, here is your master engineering schematic. Your contribution guide at the root level defines expectations. The templates in the .github folder auto-populate your forms. Your code ownership file automatically assigns the right reviewers. And your CI workflows execute all the linting and testing, posting status checks that actively block unsafe merges. Boom! That is your complete, automated plumbing system laid out in one place.
And finally, Section 6. Ready for the capstone.
Over the course of this explainer, we really have journeyed from the chaotic Wild West of solo coding to a robust, fully contribution-ready, multi-team repository. Let's just reiterate the core principles here. Unambiguous human rules reduce friction because everyone knows exactly what to do. Explicit code ownership speeds up triage because the right people review the right code automatically. And deterministic CI pipelines prevent regressions because bugs are caught by machines, not users. Implementing these automated interactions is absolutely crucial to ensuring a predictable, stress-free capstone build.
So, I leave you with this final systems check question. Are your automated defenses fully locked and loaded for the final capstone delivery? Seriously, take the time to verify your pipelines, test your bouncers, and refine your rulebooks. It'll save you so much pain later. If you found this explainer helpful and you want to dive deeper into building robust decentralized systems, be sure to head over to forge.college to learn more about this subject and explore our huge library of other Web3 topics. Thanks so much for hanging out with me today, and happy building!